Air conditioners function by removing heat from indoor air, not by creating cold air. The primary function of an air conditioner is to transfer heat from inside a space to the outside. Air conditioning systems also control humidity levels to enhance comfort. Effective air conditioning balances temperature reduction with humidity control for optimal comfort. Air conditioners do not generate cold air. They extract and relocate heat energy. The refrigeration cycle initiates with the compressor. The compressor increases the pressure of the refrigerant gas. Compression raises the temperature of the refrigerant gas. The compressor discharges hot, high-pressure refrigerant gas. The hot, high-pressure gas flows from the compressor to the condenser. The condenser is the next key component in the refrigeration cycle. The condenser coils, typically located outside, release heat from the hot refrigerant into the surrounding air. A fan facilitates the heat transfer process, increasing the efficiency of heat release from the condenser coils. As the hot refrigerant gas cools, it undergoes a phase change and condenses into a high-pressure liquid. The high-pressure liquid refrigerant is then ready to continue through the refrigeration cycle. High-pressure liquid refrigerant flows into the expansion valve or capillary tube. The expansion valve causes a sudden pressure drop in the liquid refrigerant. The sudden pressure drop results in the refrigerant becoming very cold and low pressure. The cold, low-pressure refrigerant enters the evaporator coils. Inside the evaporator coils, the refrigerant evaporates, absorbing heat from the surrounding air. The evaporation process cools and dries the air blown over the evaporator coils. As warm air flows over cold evaporator coils, moisture condenses into liquid water. The condensed water is collected as drainage, which results in decreased humidity. This dehumidification process is governed by the second law of thermodynamics. Heat is transferred from cooler indoor air to warmer outdoor air, requiring energy input. Energy efficiency is quantified by the amount of cooling achieved per unit of electricity consumed. Inverter ACs save energy by intelligently adjusting the compressor speed.